In this segment, we'll talk about how do we find the inverse of a matrix. If A is a n by n matrix, so if we have a square matrix and we claim that A inverse is the inverse of A, then we know that, hey, A times A inverse will be equal to the identity matrix. So the question arises that how do we find out the inverse of a matrix, or at least get an idea of how we should go about doing that. So if we consider the A matrix, let's suppose for a n by n matrix to be of this form. So we have A11 going all the way up to A1n, an1 going all the way to an. So we have these n by n elements, n square elements in the A matrix. And then if we have the A inverse matrix, and that also has n square elements, let's call it like A11 prime all the way up to A1n prime, then an1 prime and ann prime. Then how are we able to find out what the inverse of the matrix is? All we have to do is to multiply this matrix by this matrix and put it equal to the identity matrix. So that's how we should be able to do that. So if we have this matrix here, A11 all the way up to A1n, then an1 all the way up to ann, I'm going to multiply it by the inverse of the matrix, which will be A11 prime, A1n prime, an1 prime all the way up to ann prime, and I'm going to put that equal to the identity matrix. So I get 1, 0, all the way to 0, 0, 1, 0, and all the way 0 here and 1 here. So what I basically have is that I have an n by n matrix, which I'm multiplying by its inverse, and I'm supposed to get the identity matrix right here. So the question arises, how do I find out what the inverse of the matrix is? So what I can look at it this way is that I can now rewrite finding the inverse of the matrix as a system of simultaneous linear equations as follows. I can say, hey, let me take the first column of the inverse matrix. So if I take the first column of the inverse matrix and I multiply it to the A matrix, it will basically give me the first column of the identity matrix, which makes sense because if I take the first row here and first column here, I'll get the first row, first column here. If I take the first row here, second row here and first column here, I'll get the second row, first column here. If I take the nth row here and the first column here, I'll get the nth row, first column here. So what that's going to do is that if I now write down only the first column here of the inverse matrix, then I'll only get a column matrix on the right side also. So if this is A11 and I goes to the A1n, and this is an1 and that's ann, I'll write this as A11 prime all the way up to an1 prime. So that's my first column of the inverse of the matrix. Then this one will be just 1, 0, 0, 0, 0. So what that means is in order to find the first column of the inverse of the matrix, I'll have to solve n equations and unknowns, which will be of this particular matrix form. And what does that mean in terms of finding the other columns of the inverse of the matrix? If I would have put the second column of the inverse of the matrix here, then in this case the right hand side would become 0, 1, 0, 0, 0, so on and so forth. And so what that means is that I'll have the second column of the identity matrix would be my right hand side vector. So if I continue doing that, I'll be able to set up n equation n unknowns, but I'll have n such sets of n equation n unknowns, and I'll be able to find the inverse of the matrix. And that is the end of this segment.